Okay, so graphing reciprocal functions. So what are we talking about? We're talking about having the variable in the denominator, right? So now we've got a situation where we've got the variable in the denominator. And that changes things. And that means there are excluded values, and excluded values are things that we have to deal with. All right, so reciprocal function, the values of the independent variable that result in division by 0 is an issue. And these values, whatever is going to cause you to have division by 0, form vertical asymptotes. We've had the word asymptote before, A-S-Y-M-P-T-O-T-E. A-S-Y-M-P-T-O-T-E. Values that the function approach but never reaches. Approaches. So values that the function approaches but never reaches, right? The asymptote is that imaginary line. It's imaginary, but it's that imaginary line where the function keeps getting closer and closer and closer, but never gets there unless you want to go all the way to infinity, and then it would get there. Okay, so let's take a look at this first example here. We've got y equals 1 over x. Pretty simplistic. Okay, so on this one, the asymptote is just going to be x equals 0. And that's why I have that red vertical line there. So that dotted red vertical line is the asymptote. Okay, and then you also have what we call the end behavior. And we're also going to have the same issue at y equals 0. I'll explain this a little bit further later on. But now we have a horizontal asymptote. And that's a little bit more involved on that one. So I'll show you that a little bit later. Okay, we can see that both of these asymptotes intersect at the origin. So the intersection is the center. The center of the hyperbola. Though I will say that not every one of these is a hyperbola. So I probably would have been better off just saying the center of the graph. Put parentheses graph. The center is an imaginary point. The center is not a point to where if you put the x, y values into the function, it will solve the function. So I'll explain that a little bit more when we graph this, because I think you'll see it a little bit more clearly. All right, so we're going to go through just an XY chart here. All right, so I'm starting here in the negative territory. You stick in -4, you get -1/4. All right, so when x is -4, we're at -1/4. Somewhere about right there, right? Somewhere about in there. Let me go higher for you guys. Actually, let me get this thing where I need it to be. Okay, so got -1/4. All right, next we do -2. We get -1/2. When we do -1, we get -1. When we do -1/4, all right, so just to be clear, this is 1 over -1/4, which ends up being -4. You okay with that? Say again. Oh, okay. I'm like, no, 1 over -1/4 is good. All right, so I started off, and I'm going to keep on going. Yeah, all right, hold on. All right, wait, -4, -2, 1/2, -1. Oh, what? I got you. I'm with you. All right, that's why when you get off, you just stay off. Thank you. All right, how about there and there? Now I'm with you. All right, good. Thank you. All right, so this one is -4. (-1/4), (-4), and we're down here somewhere about like that. All right, now we good? All right, I like it too. So we're approaching that asymptote that way. We're coming around like this, and we're approaching that asymptote that way. That's only half the graph. Okay, that's half of it. And we've got to do the rest to figure out the rest. Okay, the only reason I put 0 in here, what's going to happen when you put in 0 for x? 1/0, and you get infinity, which is really the asymptote. Okay, positive numbers now. If x is 1/4, 1/1/4 is 4. So now we get 1/4, 4, and we're up here. Stick in 1, you get 1. And can you see how we're kind of mirror imaging? 2 would be 1/2. And 4 would be 1/4. So now we're coming like this. Okay? That's one graph. That's one function. It's separated by the asymptotes. But it's one function. So now you see that the center point isn't a point on either one, right? But it definitely is the center between the two. So again, the center point's an imaginary point. It's more of a, I don't know how to put it. We'll see it later when we translate. We're going to translate off the center point. So if we translate this function, let's say it was translated 1 to the right and 2 up. Don't do this in your notes. You would go 1 to the right and 2 up. You would put the center there, and then both would move from there, same amount. 1 up and 2 to the right. Right. Anyhow, so center point is an imaginary point. Let's go ahead and write the domain here. So domain. Got to use set builder notation. Set of all x's such that x, and this is an odd one. Really what we have to say is what it's not. X does not equal what? What doesn't x equal? 0. It equals everything else. So by saying that, we're intimating that it's every other real number except 0. If you want to put all the real numbers and not 0, feel free, but that's what that means. So because again, look at the left, right? Going left on the x values. We have any value just to the left of the origin left and forever to the left. And going to the right, we have the value just to the right of the origin and forever to the right is where the function is. Everything except 0. And the range is going to be the same deal. Set of all y's such that y does not equal 0. Because again, we go just below 0 forever down, just above 0 forever up. Just below 0 forever down, just above 0 forever up. All right, feel free to ask questions as we go. Transformation form. All right, so the A is in the top. We're used to A. We know that A is going to involve the, it used to be steeper, wider, that kind of situation. Where would you expect the H would go? With the X, right? So H is down there, and it's got to be plus K because math makes sense. And so that's the form. This is a simplistic form. These can get pretty complex and pretty complicated. So this is a simplistic form. All right, but in this simplistic form, the center, again, an imaginary point, is of course going to be HK with a vertical asymptote. Vertical, right? Vertical asymptote up and down of x equaling h. And the horizontal asymptote of y equals, of course, k. Now again, simplistic view, because these asymptotes can become a little bit more complex depending upon the complexity of the function. We're doing just the basics right now. All right. When you guys go on to advanced math next year, you'll play around with these a whole lot more. Have a whole lot more fun. We just can barely scratch the surface of the fun in here. Sorry about that. We're just party poopers. All right. B, the graph is said to have a discontinuity. Discontinuity. And I hope I spell this right. Discontinuity. At x equals h. At the asymptote. A discontinuity. Okay, what do we mean by discontinuity? Well, if you look at the function, if I look down here in quad 3, your function comes out of negative infinity and comes up and heads toward the x-axis, way out in negative infinity along the x-axis. And then you have this gap. And then you have it here coming out of positive infinity and heading to the right toward infinity that way. We have a discontinuity. You can't take your pen and draw both curves without lifting your pen off the paper. There's a discontinuity. That's all we mean. It's a break in the function. Okay. Discontinuity. Don't let that word scare you. It's not a big deal. Okay. Absolute value of A. If it's greater than 1, that sounds familiar. The graph is stretched. Right? We used to say steeper for a parabola, but this is a hyperbola, so we're going to say stretched. And of course, if it's less than 1, it's going to be compressed. So stretched and compressed, not a big deal. If there's a negative with the A, then it's reflected about the x-axis, or really, in the less simplistic form, it's reflected about the value of x equal h. I'm sorry, did it backwards. Of y equals k. Really reflected about the value of y equals k. And I'll show you this in a little bit when we graph a few. Okay, so let's take a look at this first one. So first off, center point. So go ahead and state what your center point is. And everybody says what? Talk to me. Negative 1, 2. Okay, good. So that's our center point. Again, this is an imaginary point, but that is the center point. All right, and therefore we are going to have a vertical asymptote at x equals negative 1, and we're going to have a horizontal asymptote at y equals 2. So I'm just going to draw a dotted line at x equal negative 1. And I'm going to draw a horizontal line at y equals 2. Notice our center ends up right where those two asymptotes intersect, at negative 1, 2. Is that okay with everybody? Okay, so I'm expecting, this is really important if you know what to expect. So from here over, I'm expecting an asymptote either, hyperbola, excuse me. I'm expecting a hyperbola either here or here. So guess what? If I want to graph this side, what x values am I going to use? I'm going to use these, right? And to do this side, I'm expecting it here or here. Now, if the first one's here, I know the other one's here. If the first one's here, I know the other one's there, right? And I'm going to use these values of x. So I'm just going to do two different xy charts. So again, I'm going to do the left first because I'm orderly, left to right. And so we're just going to throw a couple values in here. Let's use good old negative 2, right? Because that's the first value to the left of the asymptote. All right, so what do we get? We get 1 over negative 2 plus 1 plus 2. So that's a negative 1 plus 2 is a 1. So we get the point negative 2, 1. Okay, do you see how this is going to be, quote unquote, mostly in quad 3? It's going to be a little bit in quad 2, but mostly in quad 3, right? Okay, so we know that. That's good. Negative 3. So again, you're just subbing in. No big deal here. So what, the left is negative 1/2. So the right is 1 1/2. Do you see what's happening now? You see how we're approaching the asymptote? So now if I did negative 4, so that's going to be what? A 1/3, right? Actually a negative 1/3 plus a 2. So this is going to be 1 2/3. You do that in your head, I hope. A positive 2 minus a third is a 1 2/3. I hope you can. If not, do it longhand. Good luck to you to make it longer. Okay, so 1 2/3 somewhere up here. Okay, we got that part. But we have nothing on that bottom part. And I can't use negative 1, right? If I use negative 1, I'm going to get infinity. So what do you think I got to use? I got to use negative 1.5. I don't have any choice, right? I got to use negative 1.5. Just punch it out, and we'll get the value. Running out of room here. So let's see, what do we end up with? Actually a 1 over a negative 1/2, which is a negative 2. And that is actually 0, right? And at this point, I'm going to say, I know where it's going, right? Do you know where it's going? All right. We could really get nitpicky and do a quarter, negative 1/4. I'm sorry, negative 1 1/4, but you're not going to want to do it. I don't want to do it. I know it's coming like this, right? And I know it's going like that. Everybody okay with that? And now we're just going to do the other one top right. So this one we're going to start with 0. So you get 1 plus 2 is 3. Again, I'm just looking at the original. Putting in 0. That's a 1 and that's a 2. So that's a 3. 0, 3. Going to use 1. 1/2 plus 2 is 2 1/2. So 1 is 2 1/2. If I use 2, now I have a third. I get 2 1/3. You see the mirror image? So you could probably predict what negative 1/2 would be, right? What do you think negative 1/2 would be without even running the numbers? Okay, so look. Here I was at this point, and when I did the half, it took me below and halfway. Here I am. If I do a half, it's going to take me above and halfway. It's going to be 4. You can run the numbers if you want. Well, I'm not running the numbers because I know they're mirror images. Okay, there's our second one. Again, run the numbers if that didn't make sense to you. But they're symmetrical and they're mirror images. Okay, hold on a second. Let's write a domain. Set of all x's such that x, talk to me domain, x doesn't equal negative 1. All right, and the range is set of all y's such that y doesn't equal 2, right? Isn't that beautiful? These are so awesome. Okay, I gotta be careful with time. Come on, screen. All right, so next one. Notice the negative here. So this is going to be reflected about y equals 1. And you'll see that in a moment. Reflected about y equals 1. Center point, talk to me. What do you think? Center point. 0, 1, right? Okay, so we got an asymptote at 0. We got an asymptote at y equal 1. Notice how you start these. This is where you got to start. Otherwise, you're just going to have a mess. Start with the asymptotes. Eddie, you that far ahead? Okay. My brain was saying either he forgot his notes or he's that far ahead or he's on strike. I don't know. You know, he's probably doing his speech in his mind. All right. Now you have that thing down pretty good. Okay, so at this point, XY chart. XY chart. Again, I like to do the negatives first. So negative 1. Negative 2 over negative 1 is a positive 2. 2 and 1 is 3. So negative 1 is 3. Okay, you see how we're going to be on the top left right now? Flip back a page. What was the left-hand side on that one? It was bottom left, wasn't it? All right. The switch is because of that negative sign. That's why we're going to be up here now. And the other one's going to be down here. Because of that negative sign did that. Okay. Negative 2. So now we get a positive 1. 1 and 1 is 2. So negative 2 is 2. And we'll do a negative 3. Which is what, a half? So we get 1 1/2. And I don't know about you, but I'm saying we're basically sketching anyhow. It's probably enough, right? You see the curve? All right. And again, I could play around and do negative 1/2, and I could do another value there, but we know basically where that thing's going to be. The idea is for you to be able to sketch them. All right, so same thing on the other side. If I use 1, I get a negative 2 and a positive 1 is a negative 1, so I get 1 negative 1. Whoops, I get 1 negative 1 down there. Okay, and just keep going. 2, that's a negative 1, and 1 is 0. 2 is 0. 3 is going to be, what, a half? And sure enough, do you see the mirror image? I do. And we know the domain is going to be anything except for 0, and the range is going to be any y value except for 1. Okay, I'm going to delve a little bit into that next lesson right here, and I'm going to change up what you have. All right, so I want you to change this thing. I want you to make the top x plus 2. Bless you. And I want you to make the bottom x squared plus 3x minus 2. Okay, this is a whole horse of a different color. Okay. X squared plus 3x, yes, minus 2. All right, I got to be careful with time here. I'm going to factor the denominator. And let's see, that's got to be, am I good here? I am not. Yeah, that's what happens when you make them up off the quick top of your mind. All right, hold on a second. That's got to be a negative x in the middle. My bad. Let me think for, hold on a second. It's got to be a positive x in the middle, not a 3. Just get rid of 3. All right, so what do we get? Positive 2. Come on, blue. Positive 2, negative 1. Okay, so we factored it. Would you agree with this? Right, now those go away. I hate when I change up because this isn't what I wanted either, but I'll live with it. Okay. So now that we look at this thing, what would be the center point? What would you conclude the center point is? Okay, 1, 0, right? 1, 0. What would be the vertical asymptotes? X equal 1, right? But here's the whole reason I did this problem. What about this? So we already learned, can X be a -2? No. So we have to keep in mind that X cannot equal -2. I'll show you what we do with that in a minute. It's the reason I wanted to do this one. Okay, and our horizontal is at y equals 0, right? Okay, XY chart. Let's work left. First X value to the left is 0. Now all I'm working off of is the 1 over X minus 1. Does that make sense? It's what we have left, right? 1 over X minus 1. Kirsten, ask your question? Okay. So all we're working off of is the 1 over the X minus 1. Okay, so if I put in a 0 for the X, I get -1. So 0 is -1. If I put in -1 for the X, I get 1 over -2, -1, -1, right? Which is -1/2. So -1 is -1/2. Do you already see where this is going? So if I put in -2, I get 1 over -3, which is -1/3. Do you have enough to sketch the curve? Again, I could do -1/2 or +1/2 if I really wanted to, but I definitely know that this thing goes like this, right? All right, hang in there. We'll come back in a minute and deal with the last issue of this. All right, let's do the other side. So we got to start at 2. So you get 1 over 2 minus 1, which is a 1. So you get 2, 1. We do 3. 1 over 3 minus 1, which is 1 over 2, which is 1/2. And if I did 4, I'd get 1 over 4 minus 1, which is a 3, which is a 1/3. Again, mirror images, right? So again, I know this thing looks like this. Could hit that point better. What do I do about this? What do I do about X cannot be -2? What would make sense to you? What would you do to your graph to make it to where X can't be -2? What would you do? Okay, let me give you a big hint on life. If you try nothing, you will get nothing. If you try something, you might get something. So try something. What do you think? What are we going to do about this? X cannot equal -2. Josh? Exactly, right? I mean, math makes sense. I'm just going to break that open. Oops, I broke it open in the wrong spot there. I'll fix it in a minute. I'm just going to put a circle at X equal -2. And just continue the curve. You see how there's a discontinuity there as well? There's just a circle there. at an x value of -2, because it can't have an x value of -2, because that would make the denominator of the original 0. Okay, so watch on the domain on this one. Right, this is going to be the set of all x's such that x does not equal -2, x does not equal 1. There are 2 excluded values, right? X can't be a 1, x can't be a -2. The y is a little trickier, the range. Going too fast here. Set of all y's such that y. Okay, we already know y can't equal 0. That's the easy one. Okay, what y value is this? What y value is that? Right? It was an x value of -2, so it's got to be a y value of -1/3. All right. Domain and range. Domain and range. Okay, the last one. I'm just about out of time. We're all set up, except I got to change those problems real quick. Let me just show you one thing that you need to do on this bottom one. You need to reverse the order and then factor out the negative. Reverse the order, factor out the negative. Now it's in the right format, right? So the h value is clearly 1, right? That negative just goes in the top. The h value is clearly 1, and the k is 0. All right, let me change that. Give you one more odd and change page 411, because I'm pretty sure we're going to be out tomorrow. But then again, you never know. It could be like, 40 degrees and we'll get nothing. Okay, so you're going to do 1, 3, 5, 15. 1, 3, 5, 15. 1, 3, 5, 15, and 25. 1, 3, 5, 15, 25. Got it? That's on the next one, not on this one. Not on this one. This one's normal. You need all of that. This is if we have a snow day tomorrow. That's page 415, 1, 3, 5, 15, 25. Got it?